When we talk about AI in finance, we hear a ton of promises. But really, it all boils down to one simple problem: trust. How can you actually prove that an AI's brilliant trading idea is exactly what gets executed with zero tampering along the way?
And that right there is the central challenge. A lot of projects will say, oh, the AI only proposes, the contract decides. But Aegis Vault, they ask a much tougher question. They want proof, and not just any proof. We're talking on-chain, verifiable, mathematical proof. Their entire system is built from the ground up to provide it.
All right, so here's how we're going to break this down. We're going to see exactly how Aegis Vault builds this trust, layer by layer. We'll look at how they bind AI directly to the code, how they built this super efficient design, how they outsmart the bots, and how they demand real accountability from their operators.
So let's just dive right into the heart of it. How do you take a simple suggestion from an AI and turn it into an unbreakable on-chain command?
Well, the answer lies in something called cryptographic binding. The best way to think about it is like a digital wax seal on an old-school letter. It creates this tamper-proof link between the AI's decision and the action on the chain. If anyone tries to mess with either part, that seal breaks and the whole transaction just gets thrown out. They're locked together.
And you gotta understand, this is a huge departure from how most projects do things. Most AI faults treat the AI part like this mysterious black box that happens off-chain. You can't prove which AI model did what. You kinda just have to take their word for it. With Aegis, the AI's response is literally woven into the DNA of the transaction itself.
And here it is. Here's the magic, right in the code itself. This is the structure that defines a transaction. See that very last field, attestation report hash? That is a unique digital fingerprint of the AI's exact output. If anything about that AI's response changes, even one tiny character, this whole hash changes, the signature becomes invalid, and the changes says nope. It's proof, and it's enforced by the code.
Okay, so they've nailed the proof problem. But a system you can trust also needs to be efficient and secure, especially when it's operating on multiple blockchains. Let's see how their design pulls this off.
Check this out. The core smart contract for the Aegis Vault is just 3.4 kilobytes. I mean, to put that into perspective, a lot of their competitors have these massive single contracts that are 10, even 20 kilobytes. This tiny size means lower fees for users, and it means they can deploy on all sorts of blockchains, even ones with tight gas limits.
So how on earth do they do that? With this really clever modular design. Instead of one giant, clunky contract, the main vault is super lean. It uses a command called DELEGATECALL to basically borrow the complex logic it needs from these other libraries. It's kind of like having a central tool kitchen for a whole apartment building. It's just way more efficient and way cheaper for everyone.
Now, for the bridgeless part. Usually, to work across multiple chains, you need these complex and, let's be honest, pretty risky cross-chain bridges. Aegis just sidesteps them completely by using a standard feature called an EIP-712 domain separator. You can think of it as putting a unique digital zip code on every single transaction.
And look at this. This is the beautiful simplicity of it right here in the code. That one single line, block.chainid, that's the digital zip code. It bakes the specific blockchain's ID right into the message that gets signed. That means a transaction signed for, say, Arbitrum is mathematically impossible to replay on another chain. The signature just won't match. It is powerful built-in security that costs you nothing extra.
All right, so we've got a system that's verifiable, it's efficient, and it's secure across chains. Awesome. But the world of DeFi is crawling with predatory bots just looking for a transaction to exploit. So how does Aegis outsmart these digital pickpockets?
The biggest threat here is called MEV, or front-running. Think of it like this. You're about to make a big trade. A bot sees your order before it's even confirmed, rushes in front of you, buys the same thing to drive the price up, and then sells it to you at that new inflated price. They make a risk-free profit, and you get a much worse deal.
Aegis fights back with this really clever two-step process called commit reveal. So in step 1, the vault commits a secret, unreadable hash of the trade. The bots can see that something is about to happen, but they have no idea what. Then, in a later block, the vault reveals the details and executes the trade instantly. By then, it's already too late for the bots to jump the line. It's like placing a sealed bid at an auction.
So we've covered the tech, the efficiency, the security. But what about the humans, the operators who are actually managing these AI strategies? How does Aegis make sure they're accountable? Well, the answer is pretty simple. You make them put some skin in the game.
They do this with something called a bonded manifest. And this isn't just some marketing slogan, it's a public signed promise. Operators have to commit to a specific strategy and then stake their own money against it. If they ever stray from that promise, their own money that they staked gets slashed. Poof, it's taken as a penalty. It forces them to put their money where their mouth is.
And we're not talking about some funny money here. As you can see, this stake is in USDC. We're talking real dollars. The more money an operator wants to manage, the bigger their personal stake has to be. $1 million stake for the platinum tier? That's a massive economic incentive to play by the rules and keep user funds safe.
But they don't stop there. Aegis hardens its security even further. After an audit, they added another key layer of protection. See, most vaults only check the assets that can go into a trade. The crucial difference here is that Aegis whitelists what goes in and what comes out. This closes a really subtle but dangerous loophole where a vault could get tricked into holding a malicious token after a swap.
And finally, they have this belt and suspenders approach to safety. So while the smart contract technically allows an operator with zero stake, the off-chain system that actually submits the trades runs in what's called strict mode. And this mode just flat out refuses to process a transaction for any operator who hasn't put up some stake, period. It's a protocol-level commitment to safety that goes above and beyond.
So when you put all of these pieces together, what do you get? All of these different design choices, from the cryptographic binding to the gas efficiency to the security layers, they all point back to one core idea: building a financial future that's based on verifiable proof, not just blind trust.
So what this all really boils down to is a system that's built on a foundation of solid, verifiable proof. It's not just about using AI, it's about making the AI's actions totally transparent and accountable right there on the blockchain. From the code that locks decisions to execution, to the economic incentives that make sure operators and users are on the same team, every single layer is designed to get rid of the need for blind trust.
And this really leaves us with one big question for the whole future of finance. In a world that's going to be more and more powered by AI, if a system can't mathematically prove what it's doing on-chain, can you ever really trust it with your assets? Aegis Vault's answer is crystal clear. The proof shouldn't be a promise. It should be right there in the code for everyone to see.